Welcome back, everyone. We're going to be solving LeetCode 257 binary tree paths. So given the root of a binary tree, we need to return all of the root to leaf paths, and we can do this in any order. So if we take a look at example 1, we're given the tree 1, 2, 3, and 5. We want to return the path 1 to 5 and 1 to 3. And it looks like they want this in a string output. So what we're going to do is we're going to do depth first search. So we know we need a stack for this algorithm, and what are we going to use? What kind of data are we going to use? Well, we know we're going to need the node, which is going to start at the root, and we know we are going to need some type of boolean to determine whether we visited this node or not. So we'll say it'll be initialized to false. We're also going to need some type of path variable, right? So we'll say path will initially be set to an array and they want a string output. So we'll set it equal to the root.value initially, and we want a resulting output as an array. Okay, so now we can just run our classic depth first search. While the length of our stack is not equal to 0, we're going to grab the node, the visited boolean, and the path so far. Stack.pop, and we are also going to create 2 copies of our path, one for our left subtree, one for our right subtree. So we're going to say the left path will be equal to path.copy, and the right path will be equal to path.copy. And what these are going to be used for is when we append our left and right childs, we are going to take the path from 1 to our left child. That'll go with our left child when we append it on our stack, and then the same for our right child. Okay, so now it's just a matter of checking if we have a node that is non-null. We'll say if node is not none. We also want to check if we have visited this node before. If we have, we want to do something, and what is that? We want to append the path to our resulting array, right? But we also, before we do that, we need to check if our left and right children are null, meaning we have found a leaf node. So we'll also put this condition on here and say if node.left is none and node.right is none, meaning we have found a leaf node, then we can append our path to our resulting array. And they want it in a string format with arrows pointing to the node values. So we can just say res.append the string join of our path variable. And that is looking pretty good so far. So, okay, so what if we have not visited this node before? All right, well, now we need to append the path, the updated path, and the updated nodes to our stack, right? And they say we can do this in any order, so let's do an in-order traversal. So we'll say stack dot, well, we need to check if the node.right is non-null first. Then we can append it. Stack.append. What do we want? We want the right child. We want a false value for visited. And we want the right path. Now, we need to update this right path. So let's say our right path will now be equal to the right path dot appending our right child, right? We need to update that. So we'll say right path dot append the string of, what do we want? We want the node dot right dot value. And then we can do, well, now we're doing an in-order traversal, so now we're going to have to append our visited node and update its visited status to true to our stack. So then now we'll say our stack dot append, we need the node, we need visited to true, and then we can just append our path. Now we can do what we did for our right child, we can do the same for our left child. So we'll say if node.left is not none, We will update our left path by adding the left child onto it. And then we can append that to the stack. The node.left will give it a visited status of false, and the left path. Okay, now at the end, we should be able to just return our resulting array. This is looking pretty good so far, so let's run this. And it does pass both test cases, so let's submit this. Perfect, it runs. Awesome. So what is the time complexity? The time complexity is going to be O of n, right? We are traversing every single node in our tree, and our space complexity is going to be bound to the length of our stack plus the length of our resulting output. So we can say O of stack.length plus the res.length. All right, that'll do it for LeetCode 257.